Can everyone hear me?
Yep, we can hear you very well.
Good. Cześć, everyone. My name is Rob. I work for a company here in the United States called SimpliSafe. We're a home security company. In contrast to other companies in our space, we provide a home security system that is entirely self-install. No installer comes out to your home. We provide a service associated with a base station that lives in your home, a collection of sensors that you position in various places. So an entry sensor, for example, you can place on a window or on a door. That sensor is basically two little white plastic boxes that are magnetically coupled. When you open the window, they separate, or when you open the door, they separate. That separation sends a signal to the base station. The base station then determines whether or not that represents an alarm condition. And finally, we have another Kumri fan here. Finally, we have our cloud infrastructure receives the signal and then forwards it to our dispatch partners. They're the ones who run through a script. The first thing they do is they call the primary contact, ask for the secret passphrase, and then work the event. Ultimately, if it does represent an alarm or a burglary or something like that, they will contact first responders, police, fire, or medical emergency. My team at SimpliSafe is that last link between our services and our dispatch providers. If I do my job poorly, people can lose property, and in certain instances, they can lose their lives. So I take my job very seriously. I've been coding for more than 40 years in many languages you've heard of, and probably quite a few you never have heard of. And most recently, I'm a lead developer, principal software engineer here at SimpliSafe, and most of our infrastructure is written in Node.js. But I am in the process of introducing Elixir and the ERTS as a platform for our services. The presentation I have for you today is about nerves. Let me see how I can turn on my screen. I assume everyone can see my screen. Is that correct? Cool. Nerves is a platform for developing IoT applications. It is a very popular platform for doing so. It runs, it's written in Elixir and in Erlang, and it runs on the ERTS. It brings a lot of baked-in goodness or functionality. It allows you to construct your application using its services. It allows you to load your firmware on either an SD card or directly to your microcomputer or IoT controller. Via networking, it provides wired networking. It provides wireless. It provides for the RPI 0, for example, it provides wireless networking. It provides networking over USB connection. So the USB cable appears to be a network cable as far as your host is concerned. It also provides MDNS. So you can name your devices and they appear on the network as whatever that name is, followed by .local. MDNS is the official name for what Apple innovated and called Bonjour. The platforms that Nerve supports are pretty much every Raspberry Pi, the BeagleBone, and the Activio Systems OSD 32MP1 Red, which is a high-end $275 US IoT platform. Let's see. So here we have our application. The base station that I mentioned to you previously is the most obvious piece of our equipment that lives in your home. And I took it upon myself to create a proof of concept for running our base stations. The base station goes through a number of steps depending on whether or not what state it's currently in. And all of our sensors talk to the base station, so it goes through, it includes internally a state machine, which determines what needs to happen next when a sensor signal is sent to it. This application is broken down into 6 concurrent applications that run on the ERTS. The top level application is the firmware application. This is nerves, basically. Nerves allows you to, here's our configuration, our Mixi EXS. Nerves requires the nerves, it requires shoehorn ring loggers so that you don't overwrite memory in terms of logging messages, and Toolshed, which is a fairly nice featureful IEX plugin that adds new functionality to IEX. Once you've loaded the nerves runtime, you also, the nerves module, you then reference the runtime and the pack. Both of those are features of nerves, and the runtime provides services that communicate with the hardware, and the pack is mostly the nerves compiler and the firmware uploading pieces. The platforms that come natively in nerves, and there are other platforms that are available by third parties. So you've got your usual plethora of Raspberry Pis, you've got your BeagleBone, your SD32MP1, and there's also a generic 8664 runtime. This portion of the depths is the pieces that I wrote that I added. This is my application. And since we're using WebSockets to talk to a very simple UI, I loaded Riverside, which is a WebSocket management application. So the layout of our directory structure, we've got our typical stuff. The README, which is this file. We have a directory for each one of our apps. And then I wrote a couple of helper scripts to make things easier, so I didn't have to remember all the magic incantations to call mix, and some utility functions and modules. So basically, the BS firmware application is everything necessary to create the firmware to load onto your target platform. To be able to demonstrate the fact that the ERTS runs concurrently, runs applications concurrently, and they're completely isolated from each other, there is a heartbeat application. Heartbeat application is really, really simple. It turns on an LED, waits a particular period of time, turns it off, waits another period of time, and then turns it back on again. So it's just a flashing LED. And we'll get back to that because there's a final piece of the demonstration I want to show off for that. Hardware, BS hardware is my interface to the GPIO pins on the Raspberry Pi. The demo I'm going to show runs on a Raspberry Pi 4. I've had it running on a 0 and several of the 3s. Hardware. There's a simple UI which uses Plug Cowboy, which I'll show off. And finally, there is the WebSocket service, which is built using Riverside. So the application is basically 6 separate applications that communicate with each other. The real guts of this is in the events state machine. The events state machine uses Gen state machine. I'm going to be refactoring to use states machine and or the same state machine language that AWS Lambda uses for implementing. The name escapes me at the moment, but the ability of building states and pipelines in Lambdas. The guts of this are basically here. I broke the application into a group of handlers. Each handler, can everyone see the text on this adequately? Good. I broke everything down into individual handlers. So the top level of the state machine has 6 separate states. There's the off state, where the base station is not monitoring any of the sensor signals. There's the home state. The home state monitors entry and glass break sensors, but it does not monitor motion sensors. And the idea here is that you turn your system on into home mode. Your dog or cat will not trip the alarm, and you can go upstairs and go to bed. Then there's the away state. That's where you want to leave the house. Presumably the cat's kept in a closed environment, so they don't have the opportunity of tripping the motion sensor. And all the sensors are now active. And to allow you time to leave the house, to arm the device, leave the house, lock the door, there is a countdown associated with it. Then there's the alarming state. If a sensor is tripped, there is also a countdown associated. Oh, sorry. There's a countdown associated with that as well, giving you the opportunity, if you are actually in the home, to stop the alarm before it's actually sent up to our cloud. The triggers are, there's an off button, an away button, a home button, a panic button, which automatically sends you to the alarming state. And then there's a motion sensor, entry sensor, and glass break sensor. You'll see those in a minute. And there's a special trigger for when the away countdown has elapsed. In the off state, typically this is how your base station is when you're at home, and each one of these handle events is set up to answer a number of events. If you've pressed the off button, for example, and you're already in the off state, we're going to ignore that. If you're in the off state and you press the away button, we will run the away button handler, and the next state that we're going to be moving towards is away countdown. So this is all of the brains, if you will, of the base station and how it interacts with sensors and the keypad, which contains all the buttons. Since our software and hardware is proprietary, I put together an example using some LEDs and a very simple UI, and that looks like this. So in the upper right-hand corner of the screen, you are seeing a live Raspberry Pi 4 connected to 3 LEDs. The yellow flashing LED you're seeing is managed by that heartbeat application that I described. Then we have the UI. The current state is off. We have the 4 buttons that are available on our keypad, and we have buttons that will trigger or trip one of our 3 sensors. I don't think I need this. This is just for my purposes. So first thing we should do is connect to IEX. I don't need to know the IP address because we're using MDNS, and the name that I gave the device is BSPOC, which stands for Base Station Proof of Concept. We are now connected to nerves with all of the stuff that is built into nerves running on the IEX REPL. Toolshed provides Toolshed provides these functions. Pretty much all of them are very, very similar to or modeled after Linux or Unix programs. It gives you some access to the ETS Erlang term storage. This particular instance has been up 18 hours and 16 minutes since I last rebooted it. I also have a addition to the IEX REPL capabilities. I found that logging was way too difficult to follow effectively. The log attach and log detach basically allow you to look at the logs that are being generated into a ring buffer, but they tend to be copious. So I created a couple of very simple commands that I load into the REPL at the same time. There's some long handling. There's a application that allows you to show all of the running apps. These are apps that start with BS underbar, which means they're my apps. This gives me an opportunity to go and see whether or not any of my apps have crashed easily. Log will turn on info level logging and ignore the rest. And procs will list all of the registered processes that are currently running on the ERTS. Just to show you, here's log. We're going to turn it on, and we're going to tell it that we want to run, we want to see debugging, everything from debugging up. So we're about to see the debug messages for both the WebSocket ping pong conversation, as well as those that I added to tell me that the LED is being turned on and off via the heartbeat. So let's turn that off. Now we're just going to see info messages, which I think are more interesting. So, quick demo. Our base station is currently off. If I click the off button, it'll tell me that it's going to be ignoring that. If I click the home button, the green LED will immediately light. This is our indicator that we're currently either home or away. And we can also hit the panic button, which will enter the alarming mode immediately. I don't know if you heard that, but there's a little buzzer associated with it that I added to the Raspberry Pi. So in home, if we get a motion sensor trip, it's going to be ignored because we have no interest in knowing how many people are moving around our house when we're home. On the other hand, if we hit on entry or a glass break trigger, it will immediately go into a countdown, after which it will trigger our buzzer. Glass break operates the same. Away is the mode where we have 20 seconds to leave the keypad, walk to the front door, open the front door, leave, lock the front door before the system actually becomes armed. System is now armed, so glass break and entry work, but motion works as well. And we're alarming in 10 seconds, giving us an opportunity to cancel the alarm, which I will do. So basically, Nerves provides all of the underlying infrastructure necessary to run firmware on your target device. It provides networking services. It provides a much scaled down version of Raspbian targeted to the particular platform. You can see this by going and looking at our bin directory, which contains, it's basically BusyBox running on Raspbian. And these are the BusyBox flavors, I guess. BusyBox, if you're unfamiliar with it, is a shell process which basically gives you a limited number of programs that you can run from the shell, but they're actually built into BusyBox. And in fact, every link that you see in this list of, 21 programs is actually a link back to BusyBox. So BusyBox knows the name of the program that was used to trigger it, and then will fulfill the requirements of that program. The overall directory structure looks like so. The only thing really here of note is the data directory. The data directory is the only portion of the runtime that will survive firmware updates. So it allows you to put interesting things in there that have to live from update to update. SRV, the directory, is where the service lives, and we actually happen to be in that directory right now. Working directory? No. Right, working directory. Yes. We're in SRV Erlang. As I said, this is a grossly diminished version of Raspbian, designed specifically to run this application only. I've had this, the firmware image for a fairly complex application is surprisingly small. I've run it on 4 gig SDs. let's see what else. Let's go and take a look at some more of the code. Couple of things that I've done which are a little, I guess, a little unique. One is in the Nerves created firmware directory. You have this really nice feature here, which allows you to, when it builds its firmware, it will overlay the contents of the directory here on the firmware once it's loaded onto the machine. So in the Etsy directory, etc., I've set up a script here to load my additions to the IEX REPL, but I've also defined my own symmetric cryptographic keys. This means that anyone who downloads this can actually SSH to the service securely without having to specially load their own keys. To that end, let's see where I need to config. Nerves is set up generally with 3 config files. There's the config for the entire service itself, and then there are separate configs for running the application on your host or running on your target hardware. So in this config, let's do this. I'm customizing some stuff. The firmware, I needed the firmware to know what target it was running on, so this was the easiest way of doing so. Line 26 is unnecessary. For my UI, I wanted to define what resources out of my priv directory, I'll get to that in a minute, the UI can serve. For the events state machine, we're doing a little brute force styling. So if I'm in the off state, it's black. If I'm in the home state, it's green. If I'm in the panic state, it's red. And that's where this is defined. Here are my GPIO pins on the Raspberry Pi. And I also specify the colors that I'm going to be using for the LEDs. If I'm running on the host, I want my WebSocket server to run. So here's the specification for the WebSockets. We don't, on the host system, we don't want to use GPIO because we don't got them. So we turn that off. And there is a difference between where the public path is for resources that we want to serve over the UI. And here's our, I went to that already, didn't I? Nope. This is the config for the target. When I am building this, so there's the roots overlay. This allows me to upload my resources for the UI as part of the firmware. This is an interesting experiment, and I'll talk about that later. Damn Macintosh. Let's see what else. Here is where Nerves keeps the Erlang command line switches. One of the things that Nerves disables is the ability of dropping down into the Erlang REPL. And in fact, if you hit Control C within IEX running on a nerves host, you will not halt the system. That's by design. What else? Yeah, we all went through all of that. So the only real sort of magic here is when I configure this system, I'm also loading in for the host. Actually, it's for both the host and for the target. I'm loading in some SSH credentials from the 3 machines that I usually use to communicate with the target. So I can SSH to the target without having to log in. And in fact, the target doesn't support password login. It only supports SSH using symmetric key encryption. Here I created some utilities. One of the things that was interesting to me is that there's no effective way in testing whether or not a list has values in it in a functional programming pipeline. So what I did was I created a function which works within a functional programming pipeline that will raise an error if the list is empty. Printing out a couple of, printing out our current system time in milliseconds. Here are IEX helpers. We're changing the prompt. We're fetching docs from our code to be able to support the H followed by the module convention within IEX. Anything else? I wanted to abstract the timing for the various countdowns. So I created a wrapper around timer, Erlang's timer object, which allows me to register the timer and start and stop it. And I did the same thing for the interval. Again, abstracting away the details of Erlang so that I dealt entirely with Elixir environment. I think that's pretty much all that's interesting there. Yes, this is a proof of concept, so it doesn't contain any tests. Interesting question. I'll answer that when we have questions. The basic answer is no, but I understand its operation. So finally, let's do something a little amusing. Here I have a separate terminal window, and I'm going to go into our heartbeat, and I'm going to go into the heartbeat runner. And let's say we want the heartbeat to be green, on the green LED, not on the yellow LED. I now need to copy the path for this, and I can now say boom, we now have a heartbeat running on green. So yes, this is hot swapped code. This particular mechanism of doing this is temporary or transient. If you reboot the system, this change will go away. But I just over the last couple of days figured out how to actually upload binary beam files and add them to the Erlang path and have them available for hot swapping permanently. The goal here would be to be able to make firmware updates to systems in the field without having to actually stop the device. One of the things we don't want to do if we have a security device is we don't want to wait for a minute or two to handle a firmware update. One of the interesting things about Nerves is that the way it does firmware updates is your device is the disk facility on your device is set up with 4 separate partitions. There's the data partition, which is read-write. There's the base partition, which is read-only. And then there's an A and a B partition. So every time you upload the firmware to the device, it will upload the firmware into the currently not being used partition. Once the update is successful, it will then reboot the system and change a pointer so that it now boots off of the other partition. So if you're running off of A, it uploads to B, it reboots and changes the pointer to run off of B, which gives you the opportunity of uploading to A. This is a very nice pattern. The only problem with it from our standpoint is that it requires a reboot. And the kinds of things that we do, we don't want the system to have to reboot if we're updating firmware. One of the chief problems that that we face as an IoT provider is the issue of accidentally bricking our devices during firmware updates. And that's one of the reasons why I'm promoting Elixir Erlang, the RTS, as a platform for our base stations, because if we do everything correctly, it's incredibly difficult to brick one of these devices because of the Erlang runtime. So I think I am pretty much out of time. So thank you for your attention. And if you're interested, I am always interested in meeting new people. So please feel free to link me on LinkedIn if you'd like. And I'll open the floor for questions.
Right. Thank you very much for this interesting presentation. We internally have also some interest in Nerves, so that was very nice to hear that. In general, what's your experience with Nerves? Do you feel like it's a nice platform to start using, or did you have any difficulties?
I didn't have any difficulties. There are some things that Nerves does, like not supporting hot swappable code, which I wish it did, but I tinkered around and figured out how to do it. I will say that this is the closest I've ever run the Erlang runtime system on the actual iron, rather than as part of an application running in an operating system. I know this is running in an operating system, but it's a completely scaled down operating system. And for example, one of the things I wanted to do was to be able to base 64 encode decode at the operating system level for doing some of my hot swaps. And that's not supported. Those functions are not exposed out of BusyBox. So I ultimately had to write Elixir code to be able to do that. But so far, I think Nerves is a really, really nice platform for bringing IoT applications up very quickly. I would like to see it run on smaller platforms. There is, I'm not still sharing my screen. There is a project out there called, I forget what it's called, but it's it will give you the ability of running on lower end microcontrollers, including the STM32 and the ESP32, controllers that have less than 500K bytes of available RAM. I would very much like to be able to play with that. This is an interesting question. I've been programming in Node since before it was Node, and before that in Narwhal and in Aptana Jaxer, which were both JavaScript platforms on the server side. I know Node pretty well, and it feels very, very comfortable to me. Elixir provides some things which were foreign to me when I first started with it. The lack of mutable state, the need to, for example, create a new gen server to be able to encapsulate runtime state. But once I wrapped my head around that, it progressed pretty quickly. The clear advantage of using Elixir over Node is its stability and its isolated nature. The actor model and the fact that all of the actor functions are completely isolated from each other. That basically makes the system incredibly difficult to. I am sharing my screen. I don't stop much. There we go. It makes it incredibly difficult to crash. There's one really, really easy way, and that is to exhaust the atom space. That'll crash an Erlang implementation quicker than you can say spit, but the ERTS brings so many different reliability features that I'm actively pursuing being able to run JavaScript natively as a NIF. Erlang contains two ideas, BIFs and NIFs, a built-in function and a non-built-in function, i.e. what we would call a plugin in other language platforms. So one of the things I'm working on in my spare time is to be able to run JavaScript natively within the Erlang runtime. Those are the advantages. The disadvantage is that you definitely have to wrap your head around functional programming and the use of immutable data, but that's not a hard stretch. One of the advantages of using Elixir is that it's purely functional in the sense that it supports the pipe operator, which is wonderful. It's funny how really good ideas in pretty much any field tend to be repeated over and over and over again. Pipe fitting in the Unix shell environment, message passing in Smalltalk, the pipe operator in Elixir. They're all exactly the same idea. Small things that do one thing incredibly well that are able to be linked input to output or output to input with other small things that do one thing incredibly well. It's a pattern that I've seen pop up 5 or 6 times in my career, and it's one that I always gravitate towards because it makes software development much easier. Any other questions?
Right. As for now, we do not have any more questions.
Cool.
All right. So thank you very much for your time. Thank you that you introduce us this nerves concept, and it was a great talk. Thank you for that. I hope
it was hard. It was hard to follow up Joshua's talk because he was so animated. Congratulations, Jonathan. It was a great talk.
Yeah, very energetic. But two different domains. What I like about Elixir that is trying to expand when it comes to domains of use, nerves, machine learning, Phoenix Live also, because it's kind of something different to like a normal static apps. So a lot of things going on in this community. That's what what I really like about it. And yeah, thank you for this introduction to nerves. All right.
Thank you for your attention.